Hi there. This is the 6-3 Solving Compound Inequalities instructional video. I'm hoping that everything goes well. There are several things that can go wrong here. First of all, I'm filming from home, so there's a dog in the room. Also, I'm having to use a graphic drawing tablet that is not always compatible with Active Inspire, so it seems to be working and playing nice right now. We'll see how that goes. I apologize in advance if I have to pause a lot. We're going to be starting on page 357 in your workbooks. We have solved multi-step inequalities, but these are what we're going to be calling compound inequalities now. When we have compound inequalities, we have two little inequalities that are joined either by the word and or. Okay, if you have two inequalities and they're joined by and, that means that both of those statements have to be true for it to be a solution. If it's joined by the word or, that means that one or the other has to be true, but not both. Okay. So here they're showing you the graphs of this is x is greater than -4. So we have an open circle at -4 shading to the right. This is x is less than or equal to 3. So we would have a colored in circle at 3 and showing the numbers less than 3. But if we join them with the word and now you can put the actual word and in the middle, or you can have just the x. I'll have to look at the practice problems online and see how they format them before I have you do the practice assignment. Here, if you put the two together, then only because this is an and statement, that means both have to be true. So that means that the number cannot be -4, but has to be greater than -4 and cannot be more than 3. All right. And so that's a compound inequality using the word and. We're going to do the and ones first, and then we'll do the or ones second. Okay, here's example 1. This is on page 357, running on to 358. And here we're going to hope this graphic drawing tablet is going to work nice. Here we have solve. -8 is less than or equal to h minus 2, which is less than 1. Then graph the solution set. Okay, here goes nothing. Let's hope. Okay, what you would do for starters, and let me move this just a smidge. There we go. All right, so what we would do here is we're going to write this as two separate inequalities, okay? We're going to write this as -8 is less than or equal to h minus 2. And then we're also going to write h minus 2 is less than 1, all right? Here, we're trying to get h by itself, so we're going to add 2 to both sides. Add 2 to both sides, and that will give us -6 is less than or equal to h over here. And they would have done that here on this line, so I've already got it all the way simplified. -6 is less than or equal to h. On the right, we're also going to add 2 to both sides. So we add 2 here, we add 2 here, and that will give us h is less than 3. So then when we go down here and put them together, this is an and statement. So we can just write one h. We would write the -6 is less than or equal to h. We don't write another h, then we write is less than 3. And that's where they got this. Notice they're using set builder notation, which means you would have a straight line. It's called the pike. You would have an H, and then you would have the braces. And you're going to want to make sure you're using set builder notation too, because I can promise you they will be. So then when we go to graph it, okay, -6 is going to have a solid dot. So we put a solid dot at -6, and we want to show that h is numbers greater than that. So we're going to be shading in this direction. But 3 is our other cutoff, and it's going to be an open circle here. So we're going to have an open circle at 3, and we want to show h's numbers less than 3. So what we're going to end up having is we're going to have the shading in between -6 and 3 with an open circle here and a closed circle here. That's how you do it. All right. They want us to go ahead and solve this inequality and then graph the solution set. So we're going to write two different inequalities. We're going to have -7 is less than or equal to 3x plus 2. And then we're going to have 3x plus 2 is less than or equal to 5. Right? So we want to solve for x. We do that by subtracting 2 from both sides. That gives us negative 9 is less than or equal to 3x. And then we divide both sides by 3. And 3 is positive, so we're not going to flip the sign. It gives us negative 3 is less than or equal to x for this side. Over here, we subtract 2 from both sides. That gives us 3x is less than or equal to 3. Then we divide both sides by 3, and we get x is less than or equal to 1. This is an and statement, so we're going to, and we know it's and because it was all put together in one thing. So now we can put these back together. Negative 3 is less than or equal to x, which is less than or equal to 1. Using set builder notation, we would have the pike and the x and the funny little brackets things. All right, now to graph this, we're going to put a solid dot at negative 3 because this is less than or equal to. So a solid dot at negative 3, where the heck is negative 3? Right here, I guess. And then x would be numbers greater than that, so we're going to be shading this direction. But the cutoff is positive 1, and that's also going to be a solid dot. And so then you just shade the area in between the two problems like that. Cool, right? So right away they jump into the word problems. A cereal manufacturer distributes cases of cereal to grocery stores. Each case contains 12 boxes of cereal. In order to pass the manufacturer's quality assurance test, the case must weigh between 336.4 ounces and 331.6 ounces, which includes 34 ounces for the weight of the case's cardboard box. Write an inequality that describes the weight of a box of cereal. Okay, now I'm going to have to pause this because I am going to need a calculator and I don't have one here in my office. So give me just a second. And just like that, the pen quit working. All right, and the dog is barking. Anyway, so I had to do this the incredibly hard way. All right, so we have the cereal manufacturer distributing cases of cereal to grocery stores. Each case contains 12 boxes of cereal. In order to pass the manufacturer's quality assurance test, the case must weigh between 336.4 ounces and 331.6 ounces. It can't weigh those amounts. It has to weigh in between those amounts. So we'll have no or equal to's here. Which includes 34 ounces for the weight of the case's cardboard box. So you would have 12, where B is the weight of each box, you're going to have 12 of those. So that's why we're going to have 12B here. Plus 34 indicates the 34 is that ounces or whatever that we're adding for the weight of the container. And that weight has to be greater than this and less than this. It's a very narrow margin. So this is our compound inequality here. Then we're going to break this up into two parts. We're going to take the 331.6 is less than 12b plus 34 and put that over here. Over here, we're going to have 12b plus 34 is less than 336.4. Then we have to solve. The first step for both is to subtract 34 from both sides. We're trying to get b by itself. So we subtract 34 from both sides here, subtract 34 from both sides here. That gives us 297.6 is less than 12b here, and 12b is less than 302.4. Then you divide each side by 12, and you arrive at your final solution. 24.8 is less than b, and b must be less than 25.2. Graphing it on a number line, that was tricky. 24.8, and it would be an open circle because there's no or equal to. So I put an open circle at 0.8, and then I have it graphed through 25.2, which is over here, also an open circle. All right. If we were going to type out the solution in set builder notation, you'd have the bracket, the b, the pike. 24.8 is less than b, which is less than 25.2, and then the brace on that one. All right. This is incredibly more difficult than this had to be. Thank you, pen, for not working. If I could drive to West Carrollton right now and get my other one, I would do it, but I can't get out of the driveway yet. Okay, so Keyshawn has been saving to buy his first car. He wants the total cost of the car and fees to be more than $5,000, but at most $7,000. The fees for buying a used car, such as title, registration, and dealership fees, will be $700. graph the list price of the cars Keyshawn could buy. All right, I'm going to pause this so I can type this all out, and I'll be right back. Okay, so what I've done here is we know that he's going to have additional fees of $700, okay? He said that he wants the cost of the car to be more than $5,000. So $5,000 is not an acceptable amount. He wants it to be more than, not more than or equal to. Therefore, the first amount, $5,000, if we subtract the $700 in fees, that means the cost of the car must be more than $4,300. So I've approximately places at $4,300, and I have an open circle because he wants it to be more than that. The other one, at most 7,000, means he's willing to pay 7,000. All right, so that's going to be a colored in circle. We're also going to need to subtract the $700 in fees from that one, which gives us $6,300. I roughly put this where I believe it would land, and then you would want the cost of the car to be somewhere between these 2 points. Okay. Right. Next. Okay. The other thing we're going to be looking at is inequalities where it says or. Okay, where either or can be true. All right. So they've given you an example here. X is greater than or equal to 1. X is less than or equal to -3. And finally, it's a solution if X is greater than or equal to 1 or X is less than or equal to -3, which means that the solution to this compound inequality can lie here or here, right? But it doesn't have to be both. Obviously, it can't be both. Okay, so now we're going to solve and graph a union. Well, now notice this is always going to be separated by the word or. Okay, you cannot put an or in compound inequality together without that word. Okay, and can be done without it because you can just have the one variable in the center. But if we're going to be using or, we have to have the word or. Okay, so solve 4n plus 8 is less than or equal to 16, or -3n plus 7 is less than -11. Then graph the solution set. This gets tricky for me because I've got this less than or equal to, and my keyboard won't do that. All right, I'm going to try very hard to see if maybe I can underline the less than sign and see if that works. So bear with me while I get this all filled in. Okay, so I have this all filled out for you. I'll go over it kind of slowly because I know you're trying to write. I took the first inequality and I wrote it here. I took the second inequality and I wrote it here. For the first one, keep in mind you're trying to get the variable by itself. So here I needed to get n by itself, so I'm subtracting 8 from both sides. On this one, I want to get this n by itself, so I subtract 7 from both sides. Then I end up with 4n is less than or equal to 8. Okay, so I'm going to divide both sides by 4, but I don't have a division symbol on my keyboard, so we're just going to have to imagine that I have divided both sides by 4, and that will give me n is less than or equal to 2. All right, over here, I have to, oh, you know what I didn't do? I didn't flip the sign. I should have flipped the sign on this one. My mistake. I wonder if I could fix that. There we go. There we go. Okay, now it's fixed. All right, I was so involved in trying to type math. All right, so we have -3n is less than -18. When we divide both sides by -3, we have to flip the sign. So that's why I changed the sign. Now we have n is greater than 6. Okay, we graph this one. This is a closed-in circle because there's an or equal to. This is an open circle because there is not. Okay, this is the way that you would write the solution with the brackets in set builder notation. Okay, all right. Okay, so we have solve 5x plus 1 is less than 11, or -3x plus 10 is less than or equal to -11, and then graph the solution set. Do I dare try to do this in my head? I would write those both down and I would solve for x. So let's see. On the first one, I would subtract 1 from both sides. That would give me 5x is less than 10. And then if I just divide both sides by 5, I would get x is less than 2. All right, so I'm looking for one where x is less than 2. A is looking good to me at this point. So now let's look at the second equation. I would subtract 10 from both sides. That would make this -21. And then when I divide both sides by -3, this sign would flip and I would get +7. So yes, very definitely A is our correct answer. Okay. Down here, they want you to solve and graph the solution set. Is this the same thing? Okay, it's the same thing. So what we would do is we would have x is less than 2. So we're going to need one of those little circle thingies. This is what I've been doing while you're on pause. Do that. Get this to be white, and I want this to be a white center because this is less than. So x would be less than 2. So then we do the line drawer and connect it here. All the values less than 2. Okay. Now, alternatively, the other one, this is n or equal to, so we need this to be filled in with a solid dot. See how much trouble this is? I know. And this would be where x is greater than or equal to 7. So here is 7, and we want to show x being greater than or equal to 7. So we go from here out that way. Okay. See what a giant pain in the butt that is? Yes, it is, and I didn't have to do any of the typing for that one. Okay, we just did it in our heads. All right, coming up next, overlapping intervals. Sometimes the ors overlap. All right, let's look at this example here. And it's off the page. Let me slide this. No, I can't make it bigger in the middle of the thing. All right, well, we'll have to slide this then. All right, so you're going to solve this inequality and this inequality, and then you're going to get to where you're going to graph the solution, okay? So let me go ahead and type in all of the solving. I'll pause this for just a second. Oh, where'd my pausey thing go? Oh dear, I don't see the pausey thing. Recorder is recording. Click here to. Okay, so I went ahead and filled this out. On the left, we have 4k plus 12 is less than 2. Okay, that's this inequality. Over here, we have 4 minus 2k is greater than 4. That's this inequality. Here, our first step is to subtract 12 from both sides, leaving us 4k is less than negative 10. Then I divided both sides by 4, and I got k is less than negative 2.5. My keyboard doesn't do fractions either. On the right-hand side, we had this inequality. My first step was to subtract 4 from both sides to get rid of this guy. That left me with negative 2k is greater than 0. Then I divided both sides by negative 2, but I did remember to flip the sign this time, and I get that k is less than 0. Well, when we come over here to graph these solutions, first one they show you is graphing the solution k is less than negative 2.5. They put an open circle at 2.5 and have indicated values less than that. This is the graph of k is less than 0, open circle at 0 and values less than that. But you can see that this graph plows right over the entire set of this graph. Okay, so we don't need to even talk about this guy because this guy just kind of takes over. Okay, so the solution set is any numbers less than 0. Okay, so it's just k less than 0 is your solution set, right? Because we don't need the other one, it's redundant. Okay. All right, check. Solve for m plus 7 is greater than or equal to 19, or negative m plus 5 is less than or equal to 0. Then graph the solution set. Well, I wonder if I mean, you guys can probably do this in your head too. Let me see what I can get with this first one. If I subtracted 7 from both sides, I would have 4m is greater than or equal to 12. If I divide both sides by 4, then I would have m is greater than or equal to 3. So m is greater than or equal to 3 is one of the correct solutions. All right, the other one, I would subtract 5 from both sides, and that would give me negative m is less than or equal to negative 5. But then I would multiply both sides by negative 1, and that's going to flip the sign. So I'm going to have m is greater than or equal to 5. M is greater than or equal to 5. Okay, well, if m is greater than or equal to 3, and also greater than or equal to 5, do you understand that those two overlap? Okay. I'll show you what I mean. Greater than or equal to 3 would be from here, and we go this way. Okay. But greater than or equal to 5 would go here and would go this way. So do you see this is unnecessary? Because all of the solutions in this set are in this set. All right, so we're only going to graph the 3, which would mean A is the correct solution, because M is greater than or equal to 3 kind of just tramples right over the other solutions. Right? Example 5, I pre-entered some of this. Write a compound inequality for an intersection. The graph shows an interval between two numbers. Because a compound inequality with the word "and" represents the intersection of two inequalities, its graph shows the overlap as an interval. So you'll know if you have dots on both ends and the middle part is colored in, that's an "and" inequality, okay? So step 1, analyze the leftmost endpoint of the interval. The endpoint is shown with a circle at -2, so -2 is not included in the solution. Points to the right of the endpoint are shaded, so the graph represents solutions of x is greater than -2. Okay. Analyze the rightmost endpoint. That's this one here. So we see that it's a solid dot, so we know 4 is included, and the unknown variable is values that would be less than 4, but also including 4. So points to the left of the endpoint are shaded, so the graph represents the solutions of x is less than or equal to 4. The shaded interval represents the intersection of the solutions, and you put this equation here and this equation here, creating a compound inequality of, do I dare try to type this? I'm probably going to regret this. A compound inequality of, and I'm going to use the set builder notation so that I'm showing you the appropriate way to do this. Okay, so we want to show, all right, where's my solution? I want to show that we're always going to start with a smaller one, so -2. And -2 is less than, notice I had to flip this one, x, sorry about the dog, which is less than or equal to, so I need to or equal to that one. Let me underline that one, so it's an or equal to, okay? Less than or equal to 4. And that is an and, okay? Because you see, you start with the smaller number. I put -2 is less than x, which is less than 4. Pretty cool, right? So that means that x is greater than -2 and less than 4. And I do have the, yeah, I got the little equal to thing there. So that's your compound inequality for that one. Which compound inequality describes the graph? Okay, well, we're looking for one where it's got to be an and, so we can immediately eliminate B, or cannot be correct in this case. But we're looking for one where there is no or equal to attached to the 7. Okay, so we can eliminate A also because it has an or equal to here. All right, we're down to C and D. We're trying to show that X is the values, and 9 is shaded, so 9 has to have the or equal to. The question is this one right or is this one right? Well, is X greater than or equal to 9? No, it's less than or equal to 9. So let's look at D. Is X greater than 7? Yes, it is. Is it less than or equal to 9? Yes, it is. So D is the correct solution for this one. It still continues. Oh, we're still not done with this section. This is taking hours to do this. Write a compound inequality that describes the graph. Okay, so this is a compound. This is an or, all right? So we're going to have the 8 is filled in and shaded to the left. So this would be an instance where X is less than or equal to 8, okay? And this one is going to be X is greater than 12, not greater than or equal to, because this is an open dot, okay? So I'll go ahead and I'm going to type out what I'm thinking here, okay? So we've got X is less than or equal to, so I'm going to have to do the underline. X is less than or equal to, get rid of the underline, 8, or x is greater than 12. Now, if you want to put this in set builder notation, it even gets messier, because you would have to have the pike, and then you would have to have another x, and then you would have to have the brace. So that would be it in set builder notation. Kind of yucky, huh? You always have to have the word or if it's an or. Which compound inequality describes the graph? This is another or. So I can immediately eliminate B and C. B is an and. Remember, if it just has one letter in the middle and no or, it's an and. Okay. This one says and, so I know B and C are wrong. So which one, A or D, is correct? Well, this one says x is less than or equal to -1. This says x is less than or equal to -1. This says x is less than -1. So I know A has to be the right one. I could continue checking. This says x is equal to or greater than or equal to 1. X is greater than or equal to 1. So A is the correct solution. Oh, thank heavens we're done with that. Oh, you know what? I need to have a secret word. I didn't prepare a secret word. Okay. Let's put it this way. If you watch this video, you know that my graphic drawing tablet stopped working shortly into the video. So I'm going to ask you a question about like what kind of problem did I encounter during the filming of the video, and you'll know it's that the graphic tablet did not work. Okay, so that'll be the answer to the secret question. At least I got through this. I hope you guys are enjoying your snow day. I'm sitting up here in my office filming very difficult videos, but I've just never mind. All right, go have fun. I'll see you guys later.